Welcome to Hexagon Tutorials Dart series. In this video, we will learn about asynchronous programming. Let's understand why asynchronous programming is so important. Imagine you're building an app, and this app needs to fetch data from the internet, read a file from the disk, or maybe wait for some user input. Now, these kinds of tasks take time, a few seconds, or sometimes even longer. If your app just sits and waits for each of these tasks to finish one by one, your users will start to feel it. The app becomes slow, laggy, and unresponsive. That's where asynchronous programming comes in. Instead of waiting for one task to finish before starting the next, your app can start a time-consuming task, then immediately move on and keep doing other work while that task is still running. And finally, once the task is done, your app can handle the result. This makes your app feel faster and more responsive to the user. In Dart, we do this using something called a future. Futures are Dart's way of handling tasks that complete at a later time, like fetching data or reading files. So, asynchronous programming helps your app stay smooth and efficient, even when it's doing a lot behind the scenes. Let's talk about futures in Dart. So, what is a future? A future is just like a promise. It represents a value or an error that will be available at some point in the future. It's Dart's way of saying, hey, I'll get back to you later. When you start a future, you're beginning an asynchronous operation like downloading data, reading a file, or hitting an API. Now, this future won't give you a result right away. But once the task is complete, it will either return a result if everything goes well, or an error if something goes wrong. Let's take a simple real-world analogy. Imagine you're at a restaurant. You place your order. That's like starting a future. Now, instead of just standing there and doing nothing while waiting for the food, you go and do other things, maybe chat, scroll your phone, that's the non-blocking part. And finally, when the food arrives, you either get a delicious meal, everything worked perfectly, or the wrong order, something went wrong. That's exactly how a future works in Dart. You start a task, don't block the rest of your app, and once it's done, you handle the result, whether it's a success or an error. So first, we're importing the async library. This gives us access to useful features like futures and delays. Now, the program starts and we print ordering pizza. This line simulates placing an order, just like starting an asynchronous task. Then, we use future.delathe to simulate a wait dot here. It's a 2-second delay. We are telling Dart, wait for 2 seconds, and then return a message saying pizza is ready. Now comes the then block. This runs after the 2 seconds. It receives the result, in this case, the message, and prints it out. So after a short wait, the app will show pizza is ready. We also add a catch error block. This is important. If anything goes wrong during the wait or execution, this block will catch the error and show a friendly message instead of crashing the program. And right after placing the order, we print another message, doing other things while waiting. This line runs immediately without waiting for the delay to finish. This perfectly shows how asynchronous programming works. The app doesn't pause or freeze while waiting for the pizza. It keeps going and does other work, then comes back when the task is done. This is what makes asynchronous programming so powerful. Your app stays smooth, responsive, and efficient. As you all saw, pizza is ready prints after 2 seconds. Let's change the time to 5 seconds. Now, you might have noticed, the message pizza is ready appears after a short delay. That's exactly what a future does in Dart. It lets the program wait for something to finish in the background without stopping everything else. Now let's pay attention to what just happened. You saw that the message pizza is ready was printed after a delay, not immediately. This is the true power of a future in Dart. It allows you to start a task, like fetching data or waiting for something, and continue running the rest of your code without waiting for that task to finish. In our example, while the pizza was being prepared in the background, simulated by a delay, the program moved ahead and printed, doing other things while waiting. Right away, once the task was done, the future completed and printed the final message. Pizza is ready. This is how asynchronous programming keeps your app smooth, fast, and responsive, by avoiding unnecessary waiting and using time wisely. Let's understand future chaining. In Dart, you can perform multiple asynchronous tasks in a sequence by chaining futures using the then method. This helps ensure that each task starts only after the previous one completes, maintaining a clean and readable flow. First, we define an asynchronous function that simulates fetching bread. It takes 1 second, and once done, it gives us the word bread. Next, we have another asynchronous function that adds filling to that bread. This also takes 1 second, and then returns a new string combining the bread with the filling. Now, to make the full sandwich, we call the bread fetching function first. When it's done, we pass the result, the bread, into the next function to add the filling. This is where we use the then method to chain the futures, so one task starts only after the previous one finishes. In the main function, we start by printing making a sandwich, which executes immediately. Then, we call the sandwich making function. Once the whole process is done, we print the final sandwich. And if anything goes wrong during the process, we catch the error and show an error message. Meanwhile, while all of this is happening in the background, we also print doing other things right away, showing that the app doesn't stop or freeze and can continue running other tasks. This is the power of asynchronous programming in Dart. You handle long-running operations step by step without blocking the rest of your app. And with future chaining, your code stays clean, readable, and organized. Let's understand how Dart handles errors when chaining futures. We begin with a function that simulates getting bread. It waits for 1 second and then successfully returns bread. So far, so good. Next, we have another function that's supposed to add filling to the bread. But instead of returning a value, it immediately throws an error. It simulates a failure, saying out of filling. Now, let's walk through the main execution flow. First, we call the function to get bread. Once it succeeds, we move to the next then block where we try to add filling to the bread. But here's the twist. Since the filling function throws an error, the next then block that expects the sandwich never gets executed. Instead, the flow jumps directly to the catcher block. This is how Dart's futures handle exceptions. If any part of the chain throws an error, it skips all remaining then, blocks and goes straight to catch error. So in this case, what you'll see printed is just the error message. Error, autofilling. This shows how you can gracefully handle failures in a sequence of async tasks without crashing your app. The chain continues only as long as things succeed. And the moment there's a failure, it's caught and handled cleanly. Alright, so what's happening here? First, the app prints fetching user data. That's just to show the process has started. Then, we're calling a function that takes a couple of seconds to simulate loading some user information, like from an API. But the cool part? The app doesn't pause. It keeps going and prints, continuing with other tasks. Right away. That's asynchronous behavior in action. Your app stays smooth and doesn't freeze. Then, once the user data is finally ready, then, block kicks in and prints user data loaded. And just in case something goes wrong during the fetch, there's a catch error, waiting to handle any issues and keep the app from crashing. So this is a great example of how futures keep your app running efficiently without waiting for every task to finish. Alright, let's quickly go over what we've learned about futures in Dart. First, a future represents a value that will be available later. It's like saying, hey, I'll get back to you once the task is done. Second, when that task completes successfully, we use .then to handle the result. It's our way of saying what should happen next. Third, if something goes wrong during the process, we catch and manage the error using .catchError. This keeps our app from crashing and helps us respond gracefully. Fourth, the biggest advantage of using futures is that they make our app non-blocking. While one task is waiting to finish, the rest of the app keeps running smoothly. And finally, we can chain futures using multiple .then calls when we want to perform tasks in a specific sequence. So with futures, we write code that's cleaner, more efficient, and responsive, just what we want in any modern app. We're going to make our asynchronous code simpler and cleaner using async and await. So now let's talk about async and await. These two keywords are game changers in writing asynchronous code. Instead of chaining multiple .then calls, which can get messy and hard to read, async and await let your code look clean, simple, and more like traditional step-by-step code. So what does async do? Well, when you mark a function with async, you're telling Dart, hey, this function is asynchronous, and it's going to return a future. Now comes await. You use await inside that async function to pause execution until the awaited future completes. It's like saying, hold on, wait right here until this task is done, then move to the next line. No more tangled .then, chains, just readable, straightforward code, and all the power of asynchronous programming. That's async and await in Dart, simple, elegant, and super effective. Let's break down this code and understand how async and await are working here. First, we have a function called fetchOrder. It's marked with the async keyword, which means this function will return a future. Inside it, we're simulating a delay of 2 seconds, like waiting for an order to be prepared and then returning the message order is ready. Now, let's look at the main function. Notice that it's also marked as async. Why? Because we're going to use await inside it, and Dart only allows await inside async functions. The first line prints placing order to the console. Then comes the line string order is equal to await fetch order. What's happening here? This line is pausing the execution of the function. It's saying wait until fetch order is complete, and once it returns the value, we store it in the order variable. So after 2 seconds, we get order is ready, and that message is printed to the screen. Finally, we print enjoy your meal. So what's the magic here? We didn't have to chain .then or set up callbacks. Our code looks clean and flows from top to bottom, just like synchronous code. But it's still non-blocking and asynchronous thanks to async and await. And that's the beauty of it. Simple, readable, and powerful. Let's see a real-world example simulating an API call. Alright, let's break down this code and understand how async and await are working here. First, we have a function called fetchOrder. It's marked with the async keyword, which means this function will return a future. Inside it, we're simulating a delay of 2 seconds, like waiting for an order to be prepared and then returning the message order is ready. Now, let's look at the main function. Notice that it's also marked as async. Why? Because we're going to use await inside it, and Dart only allows await inside async functions. The first line prints placing order to the console. Then comes the line string order is equal to await fetch order. What's happening here? This line is pausing the execution of the function. It's saying wait until fetch order is complete, and once it returns the value, we store it in the order variable. So after 2 seconds, we get order is ready, and that message is printed to the screen. Finally, we print enjoy your meal. So what's the magic here? We didn't have to chain .then or set up callbacks. Our code looks clean and flows from top to bottom, just like synchronous code. But it's still non-blocking and asynchronous thanks to async and await. And that's the beauty of it. Simple, readable, and powerful. Let's see how to handle errors using try-catch. Alright, let's walk through this code and understand what's happening with error handling in an asynchronous function. We have a function called fetchData, and it's marked with the async keyword, which means it returns a future. Inside it, we're using future.delayed to simulate a network request that takes 2 seconds. But instead of returning data, we're throwing an exception after that delay, mimicking a failed API call. Now, let's move to the main function. This is also an async function because we're using await inside it. The first line of main prints fetching data to the console. Next, we use a try-catch block. Inside the try, we call fetchData and wait for it to complete using await. Since fetchData throws an exception after 2 seconds, the control goes straight to the catch block. And the error message gets printed, error, exception, failed to fetch data. Then we have another print statement, app continues running. Now, here's what's really interesting. If you look at the output, you'll see that both the error message and app continues running appear after a 2-second delay. That delay is caused by the future.delayed call in fetch data. So, even though the function throws an error, the app doesn't crash. It catches the error gracefully and continues running. This is exactly why we use try-catch with async and await to handle failures cleanly in asynchronous code. Let's see how to run multiple async functions sequentially. Here we've got two functions here, make coffee and make toast. Both functions are marked with the async keyword, which means they return a future and allow us to use await inside them. In make coffee, we simulate a 1-second delay using future.delayed, and then we return the message coffee is ready. Similarly, in make toast, we wait for 2 seconds before returning toast is ready. Now, let's move to the main function. This one is also async because we're going to await the results. First, we print making breakfast. This happens instantly. Then we await make coffee. So, the program pauses here for 1 second, and once the coffee is ready, we print the message. After that, we await make toast, and again, the program waits here for 2 more seconds before printing that the toast is ready. Finally, once both tasks are done, we print breakfast is served. So what's happening overall? Even though these are asynchronous tasks, using await makes them run one after the other, just like synchronous code, but without blocking the main thread. It's clean, easy to read, and the output flows exactly like a real breakfast preparation would. This is the power of async and await in Dart, simple syntax, readable flow, and non-blocking execution. Alright, now let's take it one step further. Previously, we were making coffee first, then waiting for the toast. But what if we want to prepare both at the same time? Yes, let's make them run in parallel. In the main function, we start by printing starting breakfast. Then, instead of awaiting each function one after the other, we use future.wait to run both make coffee and make toast simultaneously. Future.wait takes a list of futures and waits for all of them to complete. So now, both coffee and toast are being prepared at the same time in the background. Once both are done, we use a simple for each to print each result. First the coffee message, then the toast message. And finally, we print breakfast is ready. And here's the cool part. You all must have noticed that the last 3 lines of output, the coffee, the toast, and the breakfast is ready message, all appear together after just a second. That's the magic of running asynchronous tasks in parallel using future.wait, faster execution and cleaner code. Now let's understand how we can send emails one by one using async and await. We have a function called sendEmail, which takes a recipient name, waits for 1 second using future.delayed, and then prints a message saying the email has been sent to that person. In the main function, we've got a list of recipients: Virat, Dhoni, Rohit, Sachin, and Sehwag. We then use a for loop to go through each recipient. And here's where the magic of await comes in. Inside the loop, we call send email with await. That means it waits for the current email to be sent before moving to the next one. So, it sends to Virat, waits for 1 second, then Dhoni, waits for another second, and continues this pattern till all emails are sent. Finally, once the loop is done, we print all emails sent. So in total, this process takes about 5 seconds, because we're sending emails sequentially, one after another. Perfect when the order of operations matters, and when each task depends on the one before it. Alright, let's wrap things up with a quick recap of what we've learned about async and await. So first, async makes a function asynchronous. That means it allows you to perform tasks that take time, like fetching data, waiting for a response, or reading a file without freezing the rest of your app. When you mark a function with async, it always returns a future, even if it eventually gives you a simple value. Second, await pauses the execution of that async function until the future is complete. So you can literally say, wait here until this task finishes, then move on. This makes your code feel synchronous, it's cleaner, easier to read, and avoids deeply nested then chains. Third, use try-catch for error handling in async code. Since things can go wrong, maybe the internet is down or a file doesn't exist, wrapping your await calls inside a try block helps you catch and handle those errors gracefully without crashing your app. Fourth, you can run tasks sequentially or in parallel based on your needs. If one task depends on the result of another, you wait one after the other. But if two tasks can run independently, like making coffee and toast, you can run them in parallel using tools like future.wait. And finally, this approach is way cleaner and easier to manage than chaining multiple then calls. Your logic becomes straightforward, readable, and much easier to debug. So, async and await, super powerful tools for writing non-blocking, efficient, and modern Dart code. Thanks for watching the video. Do like, share, comment, and subscribe to our channel.